Okay, guys, so this week we're going to be talking about domain and range, how to find domain and range, how to look at a graph and determine what the domain and range are, the difference between a relation and a function and what they are, and then the types. So this is pretty much an Algebra 1 review, but seeing as how you guys literally haven't stepped into a school since like February, I think this is very important to go over. So, okay. These are all, like, everything on this screen. Very important. The domain is all the x values, right? If you remember, the x-axis goes horizontally. So it goes left and right. So the domain is all the x values. The range is all the y values. So the y-axis on a coordinate plane goes up and down. Okay? So domain is all the x values. Very important. Range is all the y values. Here's an example in bold. So say you have those 4 points, 3, 6, and 1, 2, and 5, 8, and negative 4, 7. So the domain of these coordinate points would just be all the x values, which are 3, 1, 5, and negative 4. So if you remember, the x values always come first. Okay? And so the range of these coordinate points would be 6, 2, 8, and 7. And that's it. Okay? So moving on. So like I said, domain on the left-hand side, domain is all the possible x values of a function. And the range is all the possible y values of a function. So let's look at the domain. On the left, the domain is, it's got this like blue thick line going from like, kind of like from like spanning across the entire like curve. It's a parabola, but let's just call it a curve. So this curve right here on the left-hand side, obviously, like, this is like the leftmost right here. I wish I had, oh, I don't want border. Stop it. Oh my gosh, okay. So you kind of like span across left and right to find the domain. So the domain is, and we'll do more examples like these. And then the range goes up and down on the right-hand side. The range goes from the highest point all the way to the lowest point. And then the domain, back on the left-hand side, the domain goes from the left point, the most left point, all the way to the most right point of that function. Okay? So, this is a good picture, actually. I like this picture. Here's another one. So, it's another parabola. So, it has the domain in the purple going left and right on the x-axis, and then it has the range going up and down on the y-axis in green. So in the box, it says, notice how the domain keeps going forever in both directions, right? So it doesn't stop at those arrowheads. It keeps going, but with the arrow, it just looks like it stops because, I mean, we can't draw the lines forever, right? So we just draw the arrowheads to tell other people, okay, this goes on forever. So that's what the arrowheads actually mean, like it keeps going. So notice, let's talk about the domain. The domain literally goes forever in both directions, left and right. So it keeps going forever and ever and ever. All right? The range is a little different. Notice at the very bottom, it's at -1. So that's the most bottom point. That's its most lowest point is -1 of that graph. And then it just keeps going upwards. So notice the range going upwards also, like, it never stops. Like, it just keeps going forever. So the range is a little different because, the domain just keeps going in both directions. Excuse me. And then, but the range, which is the y values, it obviously starts at -1 and then just keeps going up. We're going to do some more. So notice, okay, yeah, here we go. So here's another curve. Remember, domain is from the left all the way to the right of that whatever graph. And then the range is up and down. Okay, so I'm going to read the box. Remember, the domain is all the x values from left to right. It's very important. Left is always goes first. Left to right. So this graph goes from -3 to +1 for the domain. Okay? And then if you hop to the bottom, it says d equals parentheses -3, 1. And the reason that it's a parentheses for the -3 is that if you look closely, the circle is actually, it's an open circle. Okay? I don't know if you guys remember that from Algebra 1. And then if you look closely at the 1, that is actually a closed circle right there on the graph. So that's why the bracket goes with the 1, because the 1 is closed. Like it's kind of like included, right? The -3, it is not included. So it's like, it's not, we call it not bounded or not restricted. Okay, so that's kind of like a very short explanation. And I'm going to talk more about the parentheses and the brackets later. But, so now let's talk about the range. So the range goes from the bottom to up. All the y values from down to up. Very important, you start from the bottom, work your way up. Just like that song, right? Like that one song, started from the bottom. Sorry. So for this graph, the range goes from -4, right? -4, and it goes all the way up. The highest point, it is at -3 again. No, I'm so sorry. Not -3. It's at 0. I apologize. That's tricky, though. I know that's going to trip you guys up. So in math language, we write the range at the very, very bottom. We write it as R equals bracket -4. So remember, the bracket goes with a closed circle, and then the parentheses goes with an open circle. Okay, and so this open circle actually, it is also goes for the 0. Excuse me. So that's kind of like a short. So that's how we write in the bold at the bottom. That's how we denote the domain and the range in like math language. Okay, this is just a refresher. This is just what I was talking about, the brackets and the parentheses. So let's look at number 1. So number 1, say you have a line and it's got endpoints, right? But the two endpoints, they're not shaded, like they're clear. So they're open circles. So number 1 in the box, it says open on both sides. Keep both circles clear, so do not shade. So you're going to use parentheses on both sides because the circles are not shaded, because they're open. So in other words, we are not specifically including A or B, right? So let's hop to number 2. Number 2, line with endpoints on both ends, and they're both shaded. So they're closed circles, shaded circles on both sides. So in this case, we're going to use brackets because it does include A and B. And I'm using the word include. I wish I could show you like in person. And we will talk about this more in person, like when we finally are in a classroom. But for now, just try to get used to the word like including and not including. I hope that's clear enough. And number 3, so same line segment, except A is shaded and B is open. So again, we're only going to give a bracket to the shaded part. Okay, so does not include B, so we're going to use the parentheses because it's an open circle. So we're only going to shade the included part, right, which is A. And then number 4, same, so except, a little vice versa. A is open, B is closed. So we're going to shade B, and then we're going to give B the bracket. And we're going to give A the parentheses. We're going to keep A open. Okay, functions and relations. So I'm just going to read from the screen. Math is all about relationships and classifying different types of those relationships. So there's literally like hundreds of different types of relationships that exist. Really thousands, really millions, if we're being really honest. Different types of relationships that exist in reality that people study that affect people's lives on like a daily basis. So math is all about finding relationships, classifying, labeling relationships, understanding and predicting the future based on the relationships that are currently like in our reality. Okay, so imagine you're looking for a boyfriend or girlfriend. There are all types of relationships you can have with them. You guys could agree to see other people, which would be an open relationship, or you guys could be official and exclusive. So you wouldn't see anybody else. You wouldn't flirt or date anybody else, right? Or you could even just start off as friends first to see if you guys click. But the most important thing, I think everybody agrees with me, the most important thing is to decide together what kind of relationship y'all want, right? So that y'all both know how the other one's gonna act around other people or how they want to act around other people. So if y'all hop into something and y'all don't know what you are to the other person, like you don't know if y'all are just friends, you don't know if y'all are exclusive, you don't know if they're seeing other people. Maybe they like you, but they're also seeing other people. Maybe you don't like that. Maybe you don't like the fact that they're seeing other people. Or maybe you don't care. Or maybe, I don't know. But the fact is, if people don't decide on what it is that they want from the other person, if they don't have that decision together, it's going to be confusion. It's going to be, what am I to you? It's going to be, who is that? It's going to be, oh, you're texting other females? Oh, she liked your Instagram post. That's how it's going to be. So until two people decide on what they want and then being clear about that, so deciding and then labeling whatever y'all have, okay? I don't care if y'all friends. I don't care if you're enemies. You got to label it. You got to know what it is to be able to understand how to behave and what should be expected, right? And then just all sorts of reasons why understanding what kind of like relationship you have with somebody, why that's so important. Otherwise, y'all both are going to be lost, right? So math is exactly that. Math is just labeling relationships, and knowing how they will act is important in predicting the future. Guys, that's all math is. Like, please understand that. Math is all about solving problems, really solving issues using logic, right? And mathematicians, they like to label things. They like to classify and define things. And so that's what we're going to do. That's kind of like and so I'm going to talk about functions and then relations. Okay? So you could think of a relation as an open relationship. No rules, and both people can act however they want to act. Right? And that's okay, because y'all decided that it's going to be open. That's all right. Okay? Or another way, you can think of a function, so second paragraph, you can think of a function as an official, exclusive couple, we all know a couple, where they gotta follow certain rules, certain guidelines to keep their partner happy, right? So one major rule that you guys can automatically think of is don't cheat. Don't flirt with other people. That's not gonna make your partner happy. Right? If it's an official, exclusive thing. So a relation, you could think of it as like an open relationship with no rules, right? And really it's just insanity. But that's all right, because they agreed together on insanity. Okay? And then you can think of a function as an official, exclusive couple where they gotta follow certain rules to keep their partner happy. Okay? So functions have a little bit more requirements. Okay? Functions have more rules they have to follow. All right, so here are the 4 types of situations. Okay? You don't want to end up in a situationship also. Please don't, because that's what happens when you don't label what it is you're doing with the other person. It's a situationship. Okay? You don't want that. I don't want that for you. Because it's confusing and it's exhausting and you deserve better. Moving on. So, on the left-hand side, you're going to see the 2 smiley faces. And the first box is called 1-to-1. And then the second box is called many-to-1. So 1-to-1 is considered a function. And you can see like kind of why it's called 1-to-1. Because, excuse me, oh my gosh. Because, I'm burping. Because on the left-hand side has its own right-hand side element. Okay? So everything on the left-hand side has its own right-hand side. It's called 1-to-1. It's actually like the most favorite like type of function. It's called 1-to-1. And then there's many-to-1. This is also considered a function. Okay? So this is where 0 goes to 0, 1 goes to 1, 2 goes to 4, but then -2 also goes to 4. So this is called many-to-1 because more than one domain value, which is on the left-hand side, that left circle or oval, more than one domain or more than one x value is going to just one range value or y value. Okay? On the right-hand side, these are not considered functions. Okay? 1-to-many. This is where 9 goes to 3 and -3. That don't work. That's not going to work. Okay, so that's not a function. And then there's many-to-many, and that's just chaos. Right? Like, I am confused. What is that? I don't want to even deal with something like that. Something confusing like that. You don't want to be a many-to-many relationship, guys. That's not, unless you agree on it. In which case, that's your decision. But just know what you're walking into. Just know. Okay? Just a little advice if you want some advice. Okay, let's do some practice problems. Is this a function? So we're going to see how the arrows are behaving. It looks like 5 goes to 2, 7 goes to 0, it goes to 1, and 10 goes to 2 also. So this is actually a many to 1. Notice how both 5 and 10, they both go to the number 2. Okay, that's why it's called many to 1. And if we go back up, we can see that, these actually is a function. Okay, so yes, this is a function. Here's another one. Is this a function? No. We're going to see because it is 1 to many. Okay, notice how the negative 2 goes to 1 and 3. Oh, I wrote it down wrong, but you can hear me talk. Notice how the negative 2 goes to 1 and 3. That is chaotic, okay? That is labeled as 1 to many, okay? That's a man having 2 girlfriends. That's chaos. That's chaotic. That's chaotic, okay? That's 1 too many. This is not a function. This is not an exclusive relationship, all right? Okay, is this a function? Let's see here. Yes, it is. Notice how each x value input, also known as domain, has their own y value, which is output. All right, so 10 goes to 15, 20 goes to 45, 30 goes to 25, and 40 goes to 35. So each one has their own partner. This is a function. This is an exclusive relationship. And is great. This is a function. This is a great function. They look very happy together. Okay, so now let's talk about the vertical line test. I hope you guys remember, but it's okay if you don't. So, vertical line test. It's a quick and easy way to look at a graph and tell if it's a function. So it's really simple. These 2 graphs at the top fail the vertical line test because that red line, that's a vertical line, that red line hits, because the graph hits the vertical line more than once. Okay, notice on the circle, notice how the circle hits that red line twice. Twice. It should only be once. Same thing here. The graph hits that red line twice, and it only needs to be once. Notice down here. Okay, so everywhere you scan that red line, the graph is only going to hit it one time. So imagine that red line just scanning like a barcode, scan it from left to right. That graph, that parabola, the purple, is only going to hit that red line once, no matter what. Same thing here. Okay, no matter where you take that red line, if you scan it, then it's going to only hit the graph one time. And so the vertical line test is a quick and easy way to tell if a graph is a function. Okay? So it only needs to hit it once. If it hits it more than once, then it is not a function. Okay, here's another example. Is this graph a function? Obviously, no. The vertical line test shows me it's not a function because I scanned it with my blue line. I scanned it like a barcode. And, so from the left, so like at -4, we good. -3, we're good. -2, we're good. -1, we're good. 0, we're good. Once we pass 0 toward going right to the right, the graph hits the vertical line 3 times. And then it's still 3 times. So no matter, even if it just fails it at any point, it fails it completely. Okay? So there's that. Let's do another one. Oh, is that the last one? Oh, wait. Do I want to do this? Nah. Okay. So I think that's it, guys. I think that's it for the, I remember the worksheet, actually. I'm thinking about it now, and it's really straightforward. It's really just about the vertical line test and domain and range, and looking at a graph and like deciding what the domain and the range is. So, I mean, it's a video. You can definitely just rewind. I was gonna say reverse. Rewind and pause if you want to write something down. But that's all we're gonna need for this week. Okay. As always, please just email me if you guys have any questions. I'm an email away. And just stay safe, and hopefully I'll see you guys in the classroom when it's safe enough to do so. And that's it, guys. So thank you for watching, and I'll see you next week. Bye.